So again, last time we looked at rational exponents. Remember, rational means a rational number is just something that could be represented as a fraction. We looked at how all those same exponent rules we've already seen are exactly the same if my exponent is a fraction. We don't change any of the rules that we worked on already. And then the very last thing that we talked about was how if I have an exponent that's a fraction, I actually could represent it as a root instead and vice versa. So that was the last thing that we looked at here. Remember, I went through our answers with a different color and sort of swapped it to that root form where I had a fractional exponent. Okay, so we have this ability to sort of convert between fractional exponents and roots. Okay, so I want to do some more practice problems together. So on page 14, I want to take a look at example 2. These 4 problems up at the top. So for example 2, part A, I am starting with cube roots. Okay, and I have terms I want to combine that are inside roots. Now we can actually just write this as since I've got a cube root times a cube root, I could just do the cube root of this whole big thing, simplify inside the root to the best of my ability. Or we can rewrite this as a fractional exponent. I'm going to go the exponent route because we've done more work converting, or I should say combining terms with exponents. So I'm going to stick with something that is more familiar to us. Again, for all of the problems that we look at today, there is more than one correct first step to many of these. There is more than one sort of approach that you can take as you're simplifying or combining like terms. I'm going to try and stick to stuff that really uses more of the things that we're familiar with, that we've worked more on, which for the most part is going to be those exponent rules. So I'm going to go ahead and rewrite this as stuff with exponents. So this would be 25 y to the 4th to the 1/3 power times 5y squared to the 1/3 power. Now I have an exponent outside of parentheses. We distribute that in. We've done that before. And that's why I switched it to an exponent, because we're more familiar with these exponent rules. We've done more work with exponents than we have with roots. So again, I'm sticking with stuff that we've seen more often, that we've done more. So I'm going to go ahead and distribute this in. This would be 25 to the 1/3 power times y to the 4 times 1/3. Remember, power to a power, we multiply. And I'll come back and simplify that in a minute. And then I would have 5 to the 1/3 power. And then I've got y squared to the 1/3 power. Power to a power, I multiply. And again, I'll come back and simplify those exponents here in just a second. Now, anytime I have a number to an exponent, it's worth it to look and see if I could simplify that term exactly as it is. 25 to the 1/3 power would be the cube root of 25, right? We just got it out of the cube root. 25 does not have a nice cube root, so I can't simplify this number as it is. I have another number to the 1/3 power. I also have 5 to the 1/3 power, okay? Now, I can't combine 25 to the 1/3 power and 5 to the 1/3 power because they don't have the same base. This would be like x squared and y cubed, right? I can't combine those because x and y are different. If the base were the same, then I could combine them. I can combine x squared with x cubed. If the base is the same, we can combine them. And looking at 25, I know that 25 is a power of 5, right? 25 is 5 squared. So what I'm going to do here is be a little tricky. And instead of keeping the 25, I'm going to rewrite it as 5 squared to the 1/3 power, which means I'm going to multiply these exponents as well. Okay, so this would be 5 to the 2/3 power. And then I'm going to multiply my exponents here. Remember, when we multiply fractions, multiply the tops, multiply the bottoms. This would be times y to the 4/3 times 5 to the 1/3, nothing to do with that right now, times y to the 2/3, 2/3 power. Now, I've got terms that have a base of 5, and I have terms that have a base of y. So I'm going to combine those like terms. So the things that have a base of 5, I'm going to add their exponents 2/3 plus 1/3 is 1. So this would be 5 to the first. And then for my y's, I've got 4/3 plus 2/3. These already have a common denominator. Yeah, so I'm just going to add the 4 and 2. That gives me 6/3. 6/3 is just 2. So I get 5y squared there. We pulled out a lot of our exponent rules on this one, a lot of those combining things. We had this little rewrite kind of trick that we pulled here. We did a lot in this problem, okay? But we didn't really do anything super new. The only kind of tricky thing I did was rewrite 25 as 5 squared. I wanted to walk through this problem with you because this idea, rewrite this as 5 squared, is something that we're going to use later in the week when we start talking about solving. Now let's talk about B. B looks a little more straightforward, looks a little more like stuff that we've seen before. I've got stuff in parentheses with an exponent outside. So we're going to distribute the exponent into every term inside the parentheses. So this would be 9 to the 1/2 power, u to the 2 times 1/2, v to the 10 times 1/2. So if I clean up my exponents here, 2 over 2 would be 1. So I get u to the first, or just u. Half of 10, or 10 over 2 would be 5. So I have v to the 5th. And then that 9 to the 1/2 power is the tricky part. Anytime, like we talked about here, anytime you have a number to an exponent, see if you can reasonably simplify that. Now, I personally am not great at looking at a number with an exponent and being able to simplify that. I have an easier time if I rewrite it in that root form. That doesn't mean that you always have to. So if you can look at that and say, oh, that means the square root of 9, which is blah, 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 then that's great. Especially for things that are not just a 1/2 power, I usually end up rewriting them. It makes it easier for me to see what it is, what root I'm taking, and then if there's a power associated with that, it just makes it easier for me to simplify. So that's what I'm going to show you here. So this 9 to the 1/2 power would be the square root of 9 to the first, right? The 2 tells me square root. The 1 tells me to the first. So it's just the square root of 9, which is 3. So I have 3 u v to the 5th. Questions for me on A or B? Okay, let's take a look at C. C, instead of, C and D are actually really closely related, but instead of having that written as something in parentheses with a power outside, we've got something with a big root. Remember that a root I could write as a power instead if I wanted to. And again, that's the option I'm going to take here. So I'm going to rewrite this x to the 4th over y to the 8th. I'm going to rewrite that all as to the 1/4 power. Okay, it's a 4th root, so that would be a 1/4 power. And now I know how to handle an exponent outside of parentheses. It goes to everything in the parentheses. So this would be x to the 4th times 1/4 over y to the 8th times 1/4, right? I distributed that 1/4 power that was outside, the both the pieces inside. Okay, we've done this before. We did it up here, right? And since I had powers already, power to a power, we multiply. So this would be 4 over 4, which is 1. This would be 8 over 4, which is 2. So our simplified version here would be x to the 1st, or just x is fine, over y to the 2nd, over y squared. Questions for me on C? Okay, let's take a look at D. D, I've got numbers, I've got x's, and then I've got y and z. I noticed here that I've got something with a negative exponent. So the first thing I'm going to do is move the thing with the negative exponent to the other part of the fraction. So this would be 6x y to the 1/2, and then z to the 5th on top. And then on the bottom, I have 2x to the 1/3. Now, I've got an x term on top and bottom. When I have an x term on top and bottom, we're going to subtract the exponents. I don't see an exponent on the x that's on the top. So what is it? I don't see an exponent. What is it? It's 1. So to combine my x's, remember we do big minus little. So I would have 1 minus 1/3. And it's going to stick on the top. So I would have x to the 1 minus 1/3. What is 1 minus 1/3? 2/3, yep. If you need to get common denominators here, right, 1 minus 1/3, 1 minus a fractional part, usually we can handle without getting those common denominators. But if it was something goofy, get your common denominators, and then we would have 2/3. So on top, I would have x to the 2/3. This y doesn't have any other terms to combine, so it just stays y to the 1/2 on the top. Z, no like terms to combine with, so it says z to the 5th on the top. And then the last thing I'm looking at are my numbers. Remember that our numbers don't have any exponents right now, so I'm not applying any exponent rules here. I'm just taking 6 divided by 2, okay? So 6 divided by 2 would be 3. And then I wrote this all anticipating that I would have a fraction, so I'm just going to throw a 1 on the bottom. But if you didn't write that, and you just gave me 3x to the 2/3, y to the 1/2, e to the 5th, that would be fine too. Question for me on D. Okay, go ahead and turn to page 15, and I have a few more I want to look at together. We looked at sort of a combination today so far of problems where we saw numbers as the base for our exponent and problems where we saw variables as the base for our exponent. Remember, I have a number as the base for my exponent. I don't do anything different. We apply all those same exponent rules, okay? So if we take a look at number 2, I know this is a little fuzzy. I'm just going to rewrite it off to the side. This is, I should say, 6 to the 3/4 power in parentheses, and then to the 1/3 power. If this were an x here instead of a 6, since I have a power to a power, I would multiply those exponents. We're going to do exactly the same thing here. So this would be 6 to the 3/4 times 1/3. I'm multiplying those exponents. Now, when I multiply here, since I have the same factor on top and on bottom, I can reduce those. So I would get 1/4 as my exponent here. You could also, if you didn't see that, multiply the tops, multiply the bottoms, you would get 3/12, which you can then reduce to 1/4. Your final answer either way should be 6 to the 1/4 power. The only thing I want you to look at when you're dealing with the number as the base for your exponent is, could I actually do that power and simplify? So if we had 6 squared here, can you tell me what 6 squared is? Yeah, it would be 36, right? So you could simplify 6 squared to 36. This would be the 4th root of 6? Can you tell me the 4th root of 6? No, I wouldn't expect you to, right? This is going to be some like nasty decimal approximation. So I'm just going to leave this as is. Let's take a look at number 3. I'm back to x's here. This is a 1/4 and a 2/4. I know it's a little hard to see here. I'm multiplying numbers that have the same base, so we add their exponents. Okay, so this would be x to the 1/4 plus 2/4. They already have common denominators, so this would just be 3/4. So my final answer here is x to the 3/4. That's it. Okay. We just used those exponent rules. And then we did a problem similar to number 4 last time, but I want to talk about the setup for number 4. So the first thing I'm going to do here with this bottom number is rewrite it as a fractional exponent. When we looked at a problem like this last time, it was D on page 13, and it was already written in exponent form. So the big difference here for number 4 is that I've got a root instead of that exponent form. So what I'm going to do is rewrite this as an exponent so I can use those exponent rules. So this would be 3 to the 1/3 power. And now I've got 3 to the first over 3 to the 1/3. I've got the same base on top and bottom. So to combine them, I'm going to subtract the exponents. Remember, big minus little. So this would be, it's going to stick where the top one was. So 3 to the 1 minus 1/3 would give me 2/3. Yeah, we just did a problem like that, I believe. So 3 to the 2/3. Okay. Now this, if I wanted to double check, would be the cube root of 3 squared. We don't know the cube root of 3. We just know it's not a nice number. So this isn't something I could simplify at all. Okay, I would just leave my answer as 3 to the 2/3. Questions for me for today? Okay, so what I want you to work on for our remaining time, and then homework if you don't finish, are the problems that we have skipped on pages 14 and 15. So back on page 14, you have 3 problems down at the bottom. Again, really similar to ones that we had done together, okay? And then on page 15, you've got, again, a few more problems, again, sort of modeling that same stuff. There's an example of each type of problem like this that we've already done together, okay? For number 9 down at the bottom, this is sort of a preview of what we're going to take a look at next, some of the steps that you need to do for here. They give you the area of this circle, and they want to know the radius. So just as a reminder, area of a circle, pi r squared, use 3.14 for pi. Okay, I know you have that key on your calculator that gives you some more decimal places. You can just use 3.14 there. Okay, so finish up the remaining problems on pages 14 and 15.